Next up, we have Kevin Irving from the International Zinc Association. So Kevin will tell you a little bit about himself before he leads into his presentation.
Good morning, everybody. This presentation is informal, so if you have a question, just raise your hand and we'll try and answer it right then and there. International Zinc Association is a nonprofit organization, so we want to promote anything that has to do with zinc coatings, galvanizing, metallizing, zinc-rich paint. And we try to give people the best practices and some of the things that are out there that are happening in the world today, because we're all taxpayers first, and we need to do something to save taxpayer dollars. Federal Highway is looking for a 100-year bridge. How are we going to get a 100-year bridge with coatings? Well, we have got case studies that shows that galvanizing and metallizing can actually give DOTs and bridges a 100-year life. Did you know that 25 to 30% of corrosion can be eliminated if the right corrosion protection system was employed right out of the get-go? Here's some guide rail. Why is it federal, highway, state, local, state engineers are specifying hot tip galvanizing guide rail, but we're painting our bridges? I mean, we know that galvanizing works. It's a proven technology, and it seems like we're just keeping going down the same place. The one thing that's good is we're starting to use zinc-rich paints, and the zinc-rich paints are giving a lot longer longevity in our bridges. A colleague of mine from Ohio, a county engineer, brought him out to this bridge and wanted to know why the 13 years later his three-part paint system is failing. But you've got the right there, that's actually hot dip galvanized, and that was put in at the same time. The hot dip galvanized is still in fine, pristine shape. How would you fix this? You can fix this. How would you fix this? This is not a trick question. You can fix this. How would you fix it? Yeah, sandblasted, but if it's in a salt-infested environment, it's recommended you power wash and remediate the salts before you sandblast it. And a lot of people aren't doing that. They're starting to come to that, but this is definitely fixable. What about something like this? This is actually in Chicago, about a mile south of United Center. With steel, this is fixable. This looks terrible, right? Oh, man. For you engineers, how would you like to go underneath this bridge? This bridge was in service the time that this shot was taken, but this is fixable. Steel is fixable. Okay, and here you can see, here's the fix. The problem that I have as a taxpayer is they replaced the steel, but they came back and they never put a coating on that part of the steel. And there's the fix. This is about 2 years later. So steel is fixable. That's the good thing I like about steel. What about this? Can you fix this? Can you make this as good as new? I don't think so. With steel you can. What about this? We might have rust, but how are you going to fix this? What about this shot? I think this is worse than any of the steel shots. This is really concerning. Does this concern anybody? How would you like to be on this bridge? So, does anybody know what the worst accident in NASCAR history is? Does anybody want to guess what the worst accident in NASCAR history is? You would think a crash or a car going up into the stands or a tire coming off. No. The worst accident in NASCAR history is a porous concrete bridge failing under 1/5 of its weight. The chlorides came in and ate the steel, and as the people were going across the pedestrian bridge, it fell. This is actually, this is about 10 years ago. I was at the International Bridge Conference in Pittsburgh, and I was going along the roadway, and I saw this mesh on top of this concrete bridge, and the mesh was actually to keep the porous concrete from falling on the cars below. I thought that was interesting, but then the next shot is really interesting. You see that below? That's not a bridge. That's a $2.7 million catch basin. That's there just to keep the concrete from falling on the cars below. This bridge has been replaced now with a steel arch bridge. And then weathering steel, we know that Federal Highway has a guide for weathering steel. Make sure you follow the guide. This is actually in Colorado, where they had 52 miles of this rail, and from the snow and the ice and the salts piling on top of this, you can see the welds are gone. They had actually replaced this rail. They had to get bond money to replace the rail. I mean, it fit in really good with the mountains and everything, but it didn't have the longevity that they had hoped for. You know, worldwide, zinc is protecting. I mean, everything that goes around, you see zinc protects. And zinc is starting to get more and more notoriety throughout the world. You know, it's been used for 150 years. This is actually a bridge in Illinois. It's hot dip galvanizing. It was actually hot dip galvanized in 1970. It's actually a little north of Champaign in Illinois. And like I said, this bridge is over 50 years old. The county engineer, Craig, told me that this bridge several times a year is underwater. And he said there's big logs and sticks and debris that's pounding on the side of this bridge, but it's still fine in pristine shape. You can see from that shot. Dr. Rob Connor from Purdue University thinks this bridge is actually going to was a Purdue initiative, because what they did is the two northbound lanes of I-69 was hot dip galvanized. This was in 1970, and the other side was used lead-based paint. In '84, they had to blast and repaint the lead-based paint. In 2002, they decided to widen the bridge. You can see the gap in between there. So when they looked at galvanizing and looked at the different technologies out there, they said, you know what we're going to do? We're going to metallize the existing portion of the bridge, and we're going to metallize the 4 new beams that we're going to put in there, and then we're going to paint them. So they duplexed that particular side of the bridge. There's the bridge today. Here's the underside of the galvanized bridge. This galvanized bridge is over 53 years old, and it's still fine in pristine shape. The sad news about this bridge is I've been able to use this as a case study for many years, but I think next year they're actually tearing this bridge down, and they're actually going to make the exits larger, which is really a shame. But Dr. Rob Conner is going to get a couple of these pieces that put in the S-Bright Center in Purdue University, where he has a lot of the bridges from the I-35 bridge and all these old bridges. But here's the mill readings on that bridge. For new steel to be galvanized today, we got to give you a 3.9 mil. 3.9 mils. Here's a bridge that's 53 years old that still has 6.82 mils. So 100-year bridge, no problem with galvanizing. Here's the Stearns Bayou Bridge. It's the first bridge we know was hot dip galvanized in the United States. Everything on this bridge was galvanized. Here's a shot of it. It's actually in Grand Haven, Michigan, so they use a lot of salts and a lot of mag chloride up there. There's the nameplate from it. And there's the pigeon poo. I mean, pigeon poo does not bother or hurt hot dip galvanizing. So that's another nice attribute about galvanizing. This is actually a bridge in Pennsylvania that was galvanized in 1971. It's still in fine, pristine shape. Solution. So hot dip galvanizing gives you this long protection because it gives you a barrier, it gives you cathodic protection, it gives you a zinc patina, and forms a metallurgical bond to the steel. Here's a bridge. As long as the paint, the galvanized, the metallized, even grease, as long as you have something to protect the substrate, it's not going to rust. If something is hot dip galvanized or metallized, you've got cathodic protection, where that scratch is going to be protected by the action of the zinc coating. And why is that? The galvanic series of metal. You've got zinc is the anode, steel is the cathode. The anode is always going to want to protect the cathode. It's a law of nature. If you take a look, a lot of boats and vessels, they have these zinc anodes, and they actually have screw holes on there because as the zinc slowly depletes, you replace them and then with other ones. And just so you know, zinc corrodes 1/30 of what steel corrodes at. That's why zinc gives you that long-lasting protection. And you got the zinc patina. So a piece of steel comes up out of hot tip galvanizing bath. The first thing that hits is the air. After the air hits it, the first patina is formed. And that patina is zinc oxide. It sits around a little while. By the time the moisture or rain gets on it, the next patina is formed. That's zinc hydroxide. Then after it sits around longer, you've got the carbon dioxide. This usually takes anywhere between 9 to 14 months, and the last patina is formed as zinc carbonate. Zinc carbonate is very stable. When you have something that's been out in the weather that's galvanized over 14 months, you don't have to worry about doing any prep to the galvanizing. Okay, if you're gonna paint over galvanizing in the first stages with a zinc oxide or zinc hydroxide, there's a prep, and you follow the ASTM D6386. But when you have the zinc carbonate stage, you just come in and power wash it and give it a coat of paint. You don't have to do any prep. So, you know, our whole thing is with galvanizing, you should never have to sandblast or abrasive blast that bridge again, as long as you maintain the galvanizing coating that's on there. You know, we feel that's a game changer, because you state DOTs, you know, the biggest cost in painting a bridge is the prep. You know, taking the old paint off and then re-prepping, setting up. Well, if you can just power wash and then repaint, how much of a savings is that going to give the states? It's going to be a lot. Hot tip galvanizing is metallurgically bonded to the steel. What do we mean by that? It's actually part of the steel. So the gamma is 75% zinc, 25% iron. The delta is 90-10. The Zeta is 94.6, and the last is the 100% pure zinc. So you're not going to have worry about water coming underneath the coating and popping and peeling and chipping it off. The zinc slowly corrodes, and it corrodes at a rate of, like I said earlier, 1/30th of what steel corrodes at. What about the hardness of hot dip galvanizing? The diamond pyramid the diamond pyramid number of steel is 159 DPM. The gamma of the hot dip galvanizing is 250. The delta is 244, and the 8 is 170. The Zeta is 179. The 8 is 70, so it's a little softer. So when you beat on a piece of galvanizing, you might get it to dent, but it's not going to pop and peel and chip off. What about the edges? You know, we grow the coating and then freeze it, so the edges are going to have the same amount of coating on as the flat surface, which is a wonderful thing, because when we look around our cities, the edges and the corners is what usually fails most, because the surface tension of paint wants to roll off. The process for anybody here been a galvanizing plant? How many people have been a galvanizing plant? A few of you. You know, for all of you that want to go to a plant, you can call me, or there's galvanizers in most states, and they'd be happy to give you guys a free tour of the galvanizing plant. It's pretty interesting. But the steel comes in on a truck, a van, a car. It goes to a process area where they tag it, gets put on a rack, and then what happens is it goes through these series of baths. So the first bath is a degreasing bath to get rid of the grease, grime, oil, or dirt. It gets rinsed. It goes into a pickling bath, either sulfuric acid or hydrochloric acid, to clean the mill scale and any oxides that are on that. Then it goes into a flux bath. The flux bath is actually preheats the steel to 160 degrees. It puts a light coating on it to keep it from oxidizing before it goes into the molten zinc. Once it goes into the molten zinc and it comes out, it's ready to go. There's no cure time. You just have to wait for it to cool and put it on the truck. Most galvanizing baths in the United States run anywhere between 830 and 840F. And to meet the ASTM 123 spec, they have to have a minimum of 98% pure zinc in their kettle. Some people add aluminum and bismuth and nickel for fluidity and reactivity and things like that. And what ends up happening is you have this intermetallic of iron zinc that actually forms inside the kettle bath. And then once the steel hits temperature, it's ready to come out. If there's any impurities on the steel, the zinc will not adhere to the steel, and we call those black spots. You know it right away. You don't have to wait. And this either needs to be fixed with the ASTM 780, with the repair of hot dip galvanizing, or the galvanizing if it's a really big spot. He'll just take it back, and they'll just rerun the piece and re-galvanize it. They'll strip the zinc off and rerun it. You know, hot dip galvanizing, you know, zinc is recyclable. That's used today. No volatile organic components is another a big thing with that. This is actually a life predictor that academia did many years ago, and what they did is they ended up looking at all these different environments: industrial, temperate marine, suburban. So if you take a look at that bridge in north of Indianapolis in the snow belt in a suburban community, okay, if you take a look at this chart, 3.9 mils in the red should give you about 95 years before you get 5% surface rust. Now, 5% surface rust doesn't mean the zinc coating has failed. What happens is that we're saying is the eta layer is gone. You still have some of the other delta and gamma. So that zinc is still there. Now it's time to come in and power wash and give it a coat of paint. And this way, that's what we're talking about. If you don't have to abrasive blast that bridge, it's a game changer. So that's at 3.9. You've got 95 years. Well, look at that bridge in Indiana. It's 53 years old, and we still have 6 mils of zinc still left on it. So there's your 100-year bridge, no problem. And there's the chart again. Remember, hot dip galvanizing is metallurgically bonded to the steel, and also has cathodic protection. So any scratch or any ding, you don't have to worry about undercutting and things like that. What about metallizing? Metallizing is really coming on strong, and one of the reasons why we see metallizing coming on strong is because industry and the states are looking for something for more longevity. So what's happening is we've got, I believe, 4, I think it's up to 5 now, bridge fabricators that actually have metallizing equipment inside their plants. So not only are they fabricating the steel for the bridges, they're metallizing it in-house. That's a game changer for the fact that now they're lower cost producers and there's more competition. Metallizing is going to continue to come down in price, which is good for all of us, because like I said earlier, we're all taxpayers. So metallizing is either zinc wire or zinc powder that gets heated up or gets arced together, and it actually atomizes the zinc, and you have molten zinc that actually gets thrown onto the substrate. It's either field or shop applied, and it's 85% as dense as hot tip galvanized. And it's a mechanical bond. It's not a metallurgical bond, so there's no alloy layers. And you got several specs out there. You got the spec from NACE, the spec from American Welding Society and SSBC. Now they've come together as AMP. But the thing that's really good in 2017, and some of the people in this room I know were on this committee, we came up with a metallizing spec for the bridge and highway folks, because they just wanted to give them something that, hey, what's a good spec if we want to metallize, a good guide, because it's all over the board as far as what to do and what not to do. There's a couple revisions with this, but this is a really good guide to get the states going if they want to go with a metallizing specification from the National Steel Bridge Alliance. And there's different names and alloys. For bridges and highway, it's usually 100% zinc or 8515, which is 85% zinc, 15% aluminum. And the 8515 is usually used if in places they have a lot of salt on the roads or by the coastal, because you're going to get a lot more longevity out of 8515 than 100% pure zinc. And this is a 100-year-old process. This isn't something that's brand new. This is a proven technology. What's happening now is these smaller pieces, because size does matter. There's no way, I think the longest bath in the United States is 62 feet long. There's no way you're going to be able to hot tip galvanize anything this big and this large. Plus, the crane capacity at the galvanizer can't pick a lot of them up. So what they're doing is they're hot tip galvanizing all these pieces here, the cross frames and the plates. They're hot tip galvanizing those at the local galvanizer, and they're metallizing all the bigger pieces. So, and you don't have to worry about building a corrosion cell because you have zinc on zinc. That's a big game changer for the bridge and highway world, because now we are getting the longevity for the bridges. So the thermal spray process, here's a piece of zinc wire. It goes through a flame. That flame atomizes the zinc, and then it gets thrown onto the substrate. This is just the equipment that's involved in flame spraying, okay, which uses a flame. And you can see right here that's actually atomized zinc that's actually come out of that flame. But for the bridge and highway world, this is a much slower process. This is for smaller stuff. For the bridge and highway world, what people are using, they're using the twin arc spray, where you have a positive and negative zinc wire that actually come out, and when they're energized and when they touch, that atomizes the zinc, and then you have clean air throwing it onto the substrate. And that's what the gun looks like. When those are powered, those two pieces of wire, when they hit, that's what arcs and throws it on the substrate. There's just a shot of the inside of the gun. But things are changing, because there's a lot of companies that are having automated processes with the metallizing. So now it's a factory control process, because you got a robot that's doing it, and you also have the manual. There's actually some wind turbines. That's actually done via metallizing via the robot, which and at the steel show last year, if the people are at the steel show, there was a guy that had a robot that actually came in and did the beam, and it flipped up and did the other side and came down. So people are looking at trying to get faster and better, and that's going to do? It's going to drive the cost down even less. And here's some people just doing some field metallizing. A lot of times these bridges that are in the field, they can be metallized. There's the Kodiak Bridge in Alaska. It's the longest bridge that was metallized, and they actually field metallized it in place, and then they sealed it in place. So another shot of field application of metallizing. You know, one of the things I just want to bring up, there's all different dew points and things. The main thing about if you're going to metallize something is you want to make sure whoever's going to abrasive blast the steel gives the steel an angular profile. You need something that's angular to get that zinc to adhere to the substrate. So an angular profile, we always say a 3.5 minimum angular profile, and then you'll have a good profile for that zinc to hang to. So you get a nice, good adhesion. You know, the times and passes, depending how fast the guy's going to go, it's anywhere between 2 to 6 mils. And some people are going to want to seal the metallizing, some people aren't. There's a lot of different sealers. I'm going to talk about later on a sealer that somebody did in Canada that I think is pretty interesting for the metallizing. And so you have all these blotches, these upside down Hershey Kisses that is actually being put on the substrate, and they pile on top of one another. And what ends up happening, you get some voids and some oxygen inclusions and some unmelted particles. So here's a micrograph of what the metallizing coating looks like. So it's not, you know, it's not like a galvanizing where you've got some inclusion and some porosity in there. That's why they say, you know, build it up a little bit. But it's still a wonderfully great coating, and it's going to give the longevity that the DOTs are looking for. This is a bridge I was on a couple years ago in Peoria. It's now about 20 years old, but the average mils on this is over 13 mils. So, and what you do is you put a center punch in there to mark where it's at, and you draw it. So every year, a couple years, you can come back and see how much depletion the zinc has lost. So this way, the DOTs will know when they got to come in and power wash and paint it to make. Because what you don't want to do is you don't want to let the metallizing and the zinc get down to where you're into the substrate, and now you got abrasive blast. It's gonna be a lot easier to come in and power wash and paint than starting to abrasive blast and do something else. It just shows you it's in great shape. Another on the other side, you know, if they used hot dip galvanized rebar here, you wouldn't have the process, the concrete peeling off of there. This is actually the James Burns Bridge in Chicago. It's called the Circle Interchange. When this job was being done, AECOM was the engineer, and they said this is one of the most complex bridges, or one of the most complex projects that was going on in all the United States, because the underground tunnels in Chicago, the water, the gas, the electric lines, and it was a huge project and a huge undertaking. And what they did in this project, because Sarah Wilson, the District 1 bridge engineer, has been since 2000, was using galvanizing in all the bridges going down to Chicago. She wanted to do something, but she knew a lot of these bridge pieces were too big. So what they decided to do was they were going to, anything that wouldn't fit in a local galvanizing bath, they were going to metallize, and that's what they did. And you got over 100 million pounds in this job. I mean, it was a huge job. I was actually on this bridge last year. I said, hey, this bridge is 3 years old. Let's get some mill takings, so this way down the road you can see where you started at and when you're going to need maintenance on it. So that's what they did. And you can see there's my marks, and there's the center punch, and there's you take 5 readings across and 5 readings down, and then you come up with the average. But that just shows you how huge this project and this undertaking was, and it's almost finished. It's like almost a 4-year project. Okay, what about other coatings? Zinc-rich paint. I mean, zinc-rich paint and zinc-rich primers is another avenue that is really working for the DOT road, and also for the ships and Navy and other places. So I got this from the National Steel Bridge Alliance, and this is an IOZ, inorganic zinc coating, that's in Kansas City, that's about 30 years old. Okay, one coat, okay, it's 30 years old. Inorganic zinc is a wonderful coating. It's just the application, the window is really tight, and you really can't come and do any field repair and things like that. But here, there shows something that, you know, it's actually working, and it's in place, and it's a very excellent coating. Here's another one that's in Washington State. It's only about 2 miles from the coast, and that's still in great and pristine shape. There's another shot of this bridge. So the zinc coatings are definitely working. So that's another thing that you might want to consider. Now, this is an organic zinc that's actually on the Biloxi, Mississippi Bridge, and about 17 years old, and that's still holding up fine. This is actually a bridge in Norway that's another organic zinc, and it's actually 29 years old, and that's still holding up well. Now, is this going to last, 100 years? No, but you know what? The thing is, when you need maintenance on this, what you can do is you can power. Don't wait till the zinc totally depletes itself. You can power wash and you can recoat over it. That's the thing that the International Zinc Association is trying to promote. Don't let the zinc totally deplete and then have to come in and abrasive blast and repaint. Well, you still got some zinc there and some life there. That's the time to come in and do your maintenance. Pardon me. This is actually a bridge in Canada, and what they did is they metallized this bridge. It's actually in Adel, Canada, and St. Adel, Canada. And after they metallized the bridge, what they did is they actually went over it with a organic zinc-rich paint. So now you got an add-on on top of an anode. And some people say it's good, some people say it's bad, but there was some testing done on this, and the longevity seemed very, very favorable. And this bridge is a couple years old now. So there are things out there. I mean, zinc protects, zinc works. I mean, in third world countries, over 800,000 people die from lack of zinc, so we need zinc. You don't want to be welding it and breathing it because, and you're not going to die from it. I thought you would when I was a welder many, many years ago. But zinc protects, and we just want to give the message, hey, it's out there. If you need any questions, you need a seminar on any of this technology and what's happening, we'd love to do that. Thank you very much.
I might have missed it, but how do you handle the connections, like splices from the hot dip?
That's a great question. They did testing on that, and to get the B, what they're doing is they're actually putting Sherwin-Williams. There's two paint companies that actually have a paint, and if you give me your card, I'll get you the application on that, because hot dip galvanizing by itself is a C. But there's a paint you put on there, and then you can get your B for your slip coefficient. Yeah, that's all been studied out. It's actually there's a paper on it, so we can get you the B, no problem. Good question.
So for the metallizing process, how long does that take to apply in relation to applying a traditional paint system, and is that an extended amount of time to actually put that in place, or? Because I know a lot of DOTs are really concerned about closure times and some of that, so.
That's a great question. Metallizing is going to take a little longer. So what ends up happening is, if you saw that one picture for the field metallizing, what happens is there's usually more metallizing people that are metallizing at the same time. So this way you can come in and do the job. But I would say metallizing is going to take a little bit longer. But you got to remember too, that coating on that bridge is going to last a lot longer, so you're not going to have to come in and mobilize. And when it does need maintenance, all you have to do is power wash and paint it. So that's another game changer. Good question. Okay, I'll be outside for any other questions. Thank you.
Thanks so much, Kevin. Really good.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.